Concept diffusion. In order to understand this concept, we're going to have to talk a little bit about vocabulary. You can't understand a concept if you don't know what the words mean that are being used to describe the concept. So let's start with the word diffusion. Diffusion means moving from an area of high concentration to an area of low concentration. In short, high to low. The body uses diffusion quite a bit for important things such as muscle contractions and nerve impulses to move ions without spending any energy. Diffusion frequently occurs between two solutions. Solutions are made up of a solute and a solvent. The solute is always the smallest percentage of a solution, while the solvent would be the largest percentage of the solution. So you dissolve a solute into a solvent to make a solution. Here's an example. If we take a 15% solution, we would break it down into 15% solute and 85% solvent. Notice that 15 plus 85 equals 100%. When you compare two solutions, one of the solutions is going to be hypertonic while the other will be hypotonic. What do these words mean? Well, hypertonic is the solution that has the highest percentage or largest percentage of solute, while the hypotonic solution will be the solution with the lowest percentage of solute. Here's another example. If we compare a 25% solution with a 15% solution, the 25% solution will be hypertonic, while the 15% solution will be hypotonic. Solutes or solvents diffuse in order to become isotonic with the other solution. When two solutions reach equal solute percentages, they are called isotonic. For example, if we have two 15% solutions on either side of a membrane, they would be considered isotonic. When we refer to membranes in biology, we're generally referring to the plasma membrane of a cell. This is a membrane that may or may not allow diffusion. There are three types of membranes. There are impermeable membranes. These membranes are membranes in which nothing can move across it. There are permeable membranes, meaning both solute and solvent can move freely across the membrane. Finally, there are semi-permeable membranes. Semi-permeable membranes are the most common type of membranes you'll encounter, and they mean that some things will be allowed to cross and some things will not be allowed to cross. In our examples, a semi-permeable membrane will be either permeable to solute or solvent, but it will not be permeable to both. So if we have a semi-permeable membrane that is semi-permeable to solute, that means solute will be able to diffuse across the membrane in both directions, but solvent cannot move across the membrane. Now let's look at an example of a diffusion problem. This is a beaker. Granted, it's not a very good beaker. I call it chuck art, but it'll serve our purposes. Inside the beaker, we're going to put a cell. That's the round object. The plasma membrane is the line of the circle around the cell, and there are two solutions that we're going to compare. Inside the beaker, we'll have a 15% solution. Inside the cell, we will have a 25% solution. The first steps to answering questions about this problem is to break down the solutions. If we break down the solutions into their solute and solvents, that will allow us to compare and determine which solution is hypertonic or hypotonic, and which way different solutes or solvents will flow depending upon the condition of the plasma membrane of the cell. The 15% solution is 15% solute and 85% solvent, while the 25% solution is 25% solute and 75% solvent. Now let's determine which solution is hypertonic and which is hypotonic. Remember, hypertonic is the solution, when you're comparing two solutions, that has the highest percentage of solute, while the hypotonic solution will have the lowest percentage of solute. What's the isotonic percentage of the two solutions? What's the percent they want to reach? That's actually pretty easy. It's going to be 20%. Now you're going to ask, how did we calculate that? Well, it's, again, very easy. It's simple to calculate. All you have to do is average the two solutions. If we take 15% solution plus 25% solution equals 40, 40 divided by 2 equals 20. That is our isotonic percentage. Now we'll look at the condition of the plasma membrane. If the plasma membrane of the cell is impermeable, which way will solute or solvent diffuse? That's pretty simple. It won't. It can't move through an impermeable barrier. Therefore, an impermeable membrane stops anything from moving back and forth. If the plasma membrane of the cell is permeable, which way will solute or solvent diffuse? If a membrane is permeable, that means both solute and solvent can flow freely across it. Now, something you have to keep in mind, if solute can flow out, it can also flow in, but there will be a net movement of solute out. meaning that the amount of solute inside the cell will decrease while the amount of solute outside the cell will increase until they reach that 20% isotonic state. At first that may sound a little confusing, but if you think about it, you'll understand that if solute can move across the membrane, obviously it's going to go back and forth, and solvent the same way. But that's where we get net movement, and net movement is what we're looking at when we're trying to reach an isotonic state. To recap, net movement means that more solute will move out than in, and more solvent will move in than out, resulting in that isotonic 20% solution in both the beaker and the cell. Now, if the plasma membrane of the cell is semi-permeable to solute, which way will the net movement of solute diffuse? There will be a net movement out of the cell until the two solutions are isotonic at 20%. If the plasma membrane of the cell is semi-permeable to solvent, which way will the net movement of solvent diffuse? Back and forth until the two solutions are isotonic. We'll get a net movement into the cell of solvent. Remember, 85% to 75%. That should explain the concept of diffusion.